Hello, my phenomenal pre-calculus class. We are ready for another online adventure. Today, we will continue solving trigonometric equations involving multiple angles. This is in our ebook, Chapter 7, Section 5. We're going to solve the equation involving a multiple angle on an interval from 0 to 2 pi, including 0 but not 2 pi. And the equation is tan of 3x equals 1. A multiple of 3, see x is a multiple of 3. Now we have to remember that the period of the tangent function is pi radians. In the interval from 0 to pi, the only value for which the tangent function uh, is 1 is pi over 4. So let's look at that on our unit circle. So here's pi over 4. Remember, the x-coordinate is the cosine and the y-coordinate is the sine. And you have to remember that tangent is the sine divided by the cosine. And so when you do the sine divided by the cosine, we get a 1. You see pi over 4. And because the period for the tangent function is pi radians, then all solutions to tan of 3x equals 1. It says 3x is equal to inverse tan of 1. Remember, when we're looking for an angle, we use our inverse trig functions. And you see this 3x is equal to pi over 4 plus k times pi. Remember, k is an integer, and remember, pi is our period for our tangent function. Then I want to solve for x. We're going to divide all three terms by 3. But dividing by 3 is the same thing as multiplying by its reciprocal 1/3. So we're going to get x equals pi over 12 plus k times pi divided by 3. So this is the solution for all of these. And we only want to find the solutions between 0 and 2 pi. So what we're going to do, we're going to use this equation here. And we're going to start off letting our k be equal to 0. And when k is equal to 0, we're going to have x is equal to pi over 12 plus 0, which is just pi over 12. This is one of our solutions because it's between 0 and 2 pi. Next, we're going to let k be equal to 1. Let k be equal to 1. We're going to have pi over 12 plus pi over 3. But we have to have like denominators in order to add the fractions. So we multiply the pi over 3 by 4 over 4. We get pi over 12 plus 4 pi over 12, which will give us 5 pi over 12. So this is a second solution to our equation. Next, we're going to let the k be equal to 2. You see, we're using our same equation for all solutions here. And we're going to have pi over 12 is equal to 2 pi over 3. And again, we have to have like denominators. So we multiply the 2 pi over 3 by 4 over 4. And we get pi over 12 is equal to 8 pi over 12, which gives us 9 pi over 12. But we can reduce this. We can divide out a 3 from each one, and we're getting x equals 3 pi over 4. So this is a third solution here. And 3 pi over 4 is still between what, 0 and 2 pi. So we're going to use this equation again. This time we're going to let k be equal to 3. So we have pi over 12 is equal to 3 pi over 3, multiplied by 4 over 4 to get common denominators. And we're going to have pi over 12 plus 12 pi over 12. This is 13 pi over 12. This is still less than 2 pi because you see 12 will go into 13, what, 1 point something? And we're looking for all the solutions between what, 0 and 2 pi. And this will be a fourth solution. Then we're going to let k be equal to 4. See, k is equal to 4. We're going to be multiplying by 4 over 4, so we'll have like denominators. So here we have pi over 12 plus 16 pi, which is 4 pi times the 4 over 12, which gives us 17 pi over 12. 12 will go to 17, 1 point something. So this is still less than what, 2 pi. So here is another solution. Let's try the k that's 5. Well, we're letting k be equal to 5 this time. So we have pi over 12 plus 5 pi over 3, multiplied by 4 over 4, so we'll have common denominators. Pi over 12 plus 20 pi, that was 5 pi times 4 over 12, gives us 21 pi over 12. We can reduce this, factor out of 3, factor out of 3. So when we get through, we have x is equal to 7 pi over 4, 7 pi over 4. So here is another solution. See, 4 going to 7, what, 1 point something, so still less than 2 pi. So let's try our k equals 6. And here we're going to have pi over 12 plus 6 times pi over 3. Now you can probably say, hey, that's 2 pi. When you add 2 pi to something, it's going to be greater than 2 pi. But I went on to get like denominators. So it'll be pi over 12 plus 24 pi over 12. And you add 1 pi plus 24 pi gives us 25 pi over 12. And 12 will go into 24, 2 point something, which is greater than 2 pi. So we stop right there. And what we have then for k equals 0, 1, 2, 3, 4, 5, the solutions of tan of 3x equals 1 in the interval from 0 to 2 pi, including 0 but not including 2 pi, will be x equals pi over 12, 5 pi over 12, 3 pi over 4, 13 pi over 12, 17 pi over 12, and 7 pi over 4. And as you are reviewing this video, always remember to stop, rewind, review. Stop, rewind, review. My love goes out to you.